All right, let's get started. Again, my name is Patrick O'Halloran. I'm with WhereScape. Thanks for joining us. I appreciate your time and attention. A couple things just before we get started. If you look at the bottom of your screen, there's a Q&A button. If you have any questions during the session, feel free to type those in, and we'll have a Q&A session at the end. Other than that, I just want to introduce Mike Ferguson briefly. Mike is a leading analyst in Europe and actually around the world in data management and analytics. Does talks and presentations around the world, and we're very happy to have him here. He's also the chairman of Big Data London. So we're very, very happy to have you here. Again, I appreciate everyone who's attending this. Mike, it's all yours.
Thanks, Patrick. So good morning, good afternoon, good evening, everyone, wherever you may be around the world. Really thanks to all of you for taking time out of your busy schedule to join us today. So I want to talk about trying to accelerate the development of data products in a data mesh using automation and data fabric. And so I'll skip over that as my company details. I want to talk about, first of all, what is a data mesh? For those of you, I know it's been widely written about, but some of you on the call may not know much about that. So please bear with me if you do. I just want to briefly cover that, then look at, why has it become an option for agile development? And what's the approach to building a data mesh? And then we'll look at data automation and how do those kind of tools work, and then how can that be used to accelerate the building of data products using data fabric in a data mesh environment. So let's get started. So data mesh was, I guess, born, if you like, in an article written in 2019 by this lady, Jean-Mike Degani, who actually is no longer at ThoughtWorks. I think she's CEO of a startup called Next Data these days. But basically, she talked about four principles of data mesh, which was domain-oriented, decentralized ownership and architecture. Basically, the idea to distribute the development of data engineering in order to produce data products. She defined data as a product, and also about the idea of using self-service infrastructure for that, kind of common infrastructure, if you like, to allow different teams to go ahead and build data products, but also to federate data governance, to have some policies which could be enterprise-wide. Obviously, things like data privacy tend to be enterprise-wide initiatives, whereas certain data products may be owned by different parts of the business, and therefore policies around perhaps access to some of that data could be governed across the business, so that not all policies are defined centrally. So given that that's the case, the idea behind data mesh in general is to decentralize the development of pipelines to build data products rather than IT doing everything. We have teams within business domains who connect to the data sources that they're very, very intimately familiar with in those business domains, and then build pipelines to produce a data product, which could then be published and made available for consumption and sharing around the enterprise. So therefore, the team building those pipelines has to design in things like governance in order to protect sensitive data, should that be within the data product they're producing. And over time, to incrementally build up a number of these data products. Now, if you scale that out, then potentially multiple teams around the enterprise would be doing this, working on different data products to add to the data mesh, a data mesh being a collection of data products that are visible and published that other people can see and use. And also that, a lot of people say, well, what's a data product? Well, I think this has been a very confusing topic, having read a lot of articles on this myself out on the internet. And so I draw a clear distinction between what I would call a data product and what I would call an analytical product. And A data product is either a physical data set or a virtual data set that's being produced, or it could also be a pipeline that's used to produce the data set, where the pipeline itself is published as a service. So that if you invoke the pipeline, it will then produce the data product on demand. Whereas analytical products, on the other hand, things like BI reports, machine learning models, prescriptive models that make recommendations or that kind of thing, even an AI bot, um, these are analytical products that have been built using data from data products. So I draw the distinction between these two. Now, if you disagree with that, forgive me, but at least for this presentation, if you would tolerate that definition, I'd be really grateful. The other thing about data products is that they can be consumed by others around the enterprise and additional data added to it to create a new data product. And that could then be published back into the data mesh for others to share, others to use within their part of the business as well. So in a way, there's kind of almost dependencies built up over time, but the idea is that clearly you can build richer data products by combining an existing one with new data to get a new data product, which is different to the one that was used to build the new one. But ultimately, data products need to be published. They need to be shareable and reusable around the enterprise so that consumers know what they are, what's out there. And of course, these data products can be published in a marketplace. They can then be consumed and used to build different kinds of analytical systems supporting different kinds of analytical workloads. So you could use them to build data warehouses. You could use them to build graph databases. You could use them to build a single machine learning model or a feature store supporting features for multiple different machine learning model initiatives in data science. You could use it to produce master data products, which can then be stored in an MDM system. There's a broad range of consumer systems, which are typically analytical workloads, that could be using those data products, so that effectively I don't reinvent. Now, why has this become a, a sort of agile development option, if you like? Well, you just have to look at what's happened over the last decade to pretty well understand that. We've over the last decade, from say 2010 to 2020 or thereabouts, we've ended up with multiple analytical systems, of which a data warehouse is just one. We master data, of course, is not an analytical system, but it can be shared by analytical and operational systems. So I can share that data across both transactional and analytical systems. But nevertheless, there are no SQL databases used for analytics, like graph databases, which are widely popular these days. For example, in cybercrime or fraud, we build streaming analytics pipelines on perhaps real-time financial data or IoT data, for example. We've got data science projects often going on in cloud storage with data science workbenches and Apache Spark, as well as data warehouse, all of this going on. And the problem has been that these have been built as silos. That is to say that the teams working on each of these silos are only working in those silos. They're not sharing tools necessarily. And so you may find that data integration tools are used in one silo, but not used in another. Maybe a different set of data integration tools used in another one of these silos. But the problem has been, given that these are sort of all centralized kind of analytical systems in a way, is that IT has often taken on the burden, or even some data scientists taken on the burden of doing all of the data engineering. But as more and more data sources emerge, what we find is that it just keeps growing. We get more and more data sources popping up, both from inside the enterprise and outside. And in addition, more and more users wanting that data to be able to analyze and add to what they already know then what's happening is that this finite set of resource in the middle is just becoming a bottleneck. And so people are saying, let's have more people around the organization skilled up to be able to do this. But at the same time, we don't want to end up with tons of different tools like we have done in the past, because there are a huge number of tools potentially out there that you could buy. The other problem is there's a lack of metadata sharing across those tools. So what some people invent in one silo is not visible to those that are using a different set of tools in another silo. And therefore they're unaware if a pipeline's already been built to produce the data that they need, and so more likely to go and build it again. So what you end up with in a siloed setup is reinvention, point-to-point data integration, where the pipelines are built for a single destination system, single purpose. And they may well easily be taking data from the same sources, but that's irrelevant. What you end up with is often data redundancy, because the same data appears in different analytical systems. Pipelines are being built potentially with different tools for different single purpose analytical systems. And there's very little in the way of sharing. Now, you could just say, well, give everybody self-service data prep tools, but we tried that 10 years ago when self-service data prep emerged. And if that's ungoverned, you end up with a Wild West in environment, everybody grabbing data from wherever, and no necessary guarantee that the data being produced is consistent. It may be okay for an individual user, but for sharing, we don't know, because if all of these tools, again, may be, being used around the organization, different tools by different users or different user groups, and no metadata sharing. And a quote here from one of my clients, a chief data officer who said that everyone in their organization was blindly integrating data with no attempt to share what they're creating. Now clearly, we don't want to do that 10 years on. We've learned our lesson from back in the 2013, 2014 timeframe. We don't want even more silos with everybody doing their own thing. And then you think, well, now how many times is the same data being integrated for different analytical purposes? If you just hand out tools and kind of say, you figure it out. And the danger is you end up with inconsistency. And naturally, people start talking about garbage in, garbage out, because they're getting inconsistent results every time. And so I suppose if I was to sum it up in a single slide as to what we've been doing with all these siloed systems over the years, is we've been reinventing. And the data that we've been producing with different pipelines for different analytical use cases is often the same data, but we don't know necessarily if the same data has been built. And so we'll go ahead and do it again and again. And so, companies have been inadvertently building the picture on the left when what they really want is the picture on the right. What they really want actually is findable, high quality, compliant, reusable data products. And so, the requirement is to build data products once. And so here you see there's a difference. Whereas previously we saw pipelines built for a single target analytical system. Here you can see that we've decoupled the source pipelines, if you like, taking data from the sources from the target. Now you see there are pipelines to build data products, and there are pipelines to take data products and consume them and use them to create, for different analytical use cases. And so data products are almost like common data product that we can share and reuse, rather than ask everybody to go all the way back to this raw data sources every time, when we could incrementally build up a set of reusable data products, in this case, an insurance example. The other thing that's been going on is we've seen some data architecture modernization going on. And so these days, as things like data lakes and data warehouses come together with open table formats and lake houses, we're seeing single systems doubling up to be able to support multiple analytical workloads, whereas in the past they weren't. But nevertheless, we're still dealing in many cases with different analytical data stores out there, albeit that some of them are coming together. So what's the approach to building data mesh? Well, typically, we've all seen the discussion, well, we need data producers and we need data consumers. And these data producers are not just centralized IT anymore. They're domain-oriented teams of, let's say, citizen data engineers, but often now have IT professionals embedded in the teams in order to help uh, the citizen data engineers adopt best practices, to help them, to help take complexity away from citizen data engineers, whereas perhaps some of the work could be done by a specialist within the team. But ultimately, there's multiple teams producing data products, and it may be that they're using a data catalog to help understand what source data is available to them and wanting to publish data products in the marketplace, which I'm not going to get into in this presentation, but which is often a data catalog application, but it's only showing you ready-made, reusable, high-quality data product instead of raw data. And then people can, shop for data that they can consume and use. And of course, it may be the case that at some point a data consumer becomes a data producer. But generally speaking, there are people producing data products and people consuming them. And so the idea is to create incrementally a set of ready-made data products that are highly valuable and people can use again and again around the enterprise. It's almost like walking into a canteen at lunchtime, as you see here, and you expect ready-made. You don't, if you fancy chicken for lunch, you don't want to walk into your canteen and somebody hands you raw chicken and some vegetables and say, here you are, you figure it out. I mean, that's crazy, right? I mean, what you expect is ready-made. But, if something is sitting here, for 30 days, would you eat it? Probably not. I mean, what you would want is metadata to explain, when was this created? How fresh is it? I mean, how was it constructed? Is there anyone I can ask questions about this for? You want additional metadata about what's being made available. The key point is that we're incrementally building up data products which are available as a service, which should hopefully speed us up. Some examples of master data and transactional data products shown on the right-hand side, which most businesses can relate to. The other thing that's emerged is, we need some kind of platform to be able to connect all these different disparate data sources, which are in multiple clouds or on premises. Could be software as a service apps, or they could be even edge data sources. And Data Fabric has often emerged as a way to do that, supporting multiple teams as a common platform to go build high quality data products from those disparate sources. And so a combination of Data Fabric software and a catalog, in some cases the catalog is bundled with Data Fabric software to allow you to be able to not only build the data pipelines to produce the data products, but also to potentially build the pipelines, consume the data products, and then assemble those data products quickly to support a different analytical workloads, whether that's data warehousing or a graph database or pulling data together for a machine learning model in data science. But the point is that you're potentially able to do all of it through a common kind of data fabric. Now, what's emerged with data mesh is a number of options to build the data products. So depending on who you talk to out there, some vendors will say, "We'll do it all on cloud storage." Maybe multiple storage accounts. So do it all on cloud storage, whether that's AWS or Azure or GCP or IBM Cloud. Do it on there. Others say, well, you don't need multiple storage accounts on just one cloud. Maybe you could do it on multiple clouds. Some people building data products on one cloud, some building on another cloud. Big global enterprises often use multiple cloud service providers, and so that could potentially be an option uh, uh, as a way of doing it. I was at the Kafka Summit in London recently, and everybody's going on about, let's build it all on Kafka topics. Let's build data products and store them in Kafka topics. So Kafka becomes the way of doing it. Or, you talk to data virtualization vendors to say, well, let's do it on, virtual data products. So that you build these virtual views representing data products, which integrate data from disparate data sources. If I go to lakehouse vendors, you see the same there. Let's do it on a lakehouse, or let's give multiple teams their own lakehouse. And so we have multiple lakehouses, and then they're all building data products within their own lakehouse and then making them available to share. So what you're seeing here is a broad range of options and a kind of a competition, if you like, to be able to use particular platform options to build data products. But what nobody's disagreeing with is that you shouldn't build data products. Everybody's saying let's build data products because it's going to save us time, right? I mean, and clearly there's a way to jumpstart this. Either you got a pre-built business glossary, or what a lot of companies are now doing is looking at data concept models, which are not detailed logical data models. They're just very high level data concepts representing data across your business, something which businesses quite easily understand, and something that resonates a lot with business professionals. So what we're seeing here is the idea that data concepts could be defined within a data concept model. And then each of those data concepts is then defined within a business glossary, within a catalog. And then you can define the attributes associated with each of those data concepts, which could ultimately therefore become data products. And then we can figure out and build the pipelines for it. So, having kind of jump-started that in your business glossary, you can then get subject matter experts around the enterprise who are domain specific professionals that understand that data intimately, can then get together and define, what's a customer, what's a product, what's an order, what's a supplier, etc., and define these within a business glossary so that we have a common set of business terms and data names and data definitions for the data products within our business. And the data catalog can often be used to discover, well, where's the source data needed to construct these particular data products that we're defining in a glossary. And obviously, a lot of data catalogs today can do automatic data discovery, even automatic data classification, to automatically detect sensitive data types and things like that. So that means that not only can I discover all the physical data names within disparate sources, but if I could also automatically map the physical data names that I discover in my data sources to business terms in the glossary, which represent data products, not only have I got common business data names defined for my data products in a glossary, but I now know where the data is that's needed to create those data products. And I know what the mappings are because, and I can increasingly do this with data catalog software to be able to understand that. Then once I've got that, I'm then in a position to allow multiple teams to work with Data Fabric to then, get this data, build the appropriate data products and publish them and make them available for different analytical use cases. And, getting a center of enablement with IT expertise embedded within the teams allows those data producers to take advantage of IT expertise rather than IT trying to do everything. They don't. They push themselves into those teams and help upskill everybody to go off and do this and hopefully do it in a fairly standardized approach that allows us to to build things quicker. And so ultimately, for the data products defined within your business glossary, we can then build the pipeline to produce that data product, whether it's for customers or products or orders or whatever it may be, and then publish those within a data marketplace. So Data Fabric has a lot of capabilities, including a catalog, of course, lets you connect to all these data sources, supports multiple teams, allows you with the catalog to automatically discover what source data is available, map it potentially to business terms in a glossary. And those teams can then take advantage of that to build pipelines to produce the data products that we can then share and reuse around the enterprise, and also share the metadata across the multiple teams if they're all using a common platform in a data mesh. So having said that, you then say, okay, I get that. So where does data automation fit in with all of this? So data automation is really about accelerating and automating the development cycle. And it could be development of data products within a data mesh, development of data warehouses and data marts, also to accelerate and automate migration of data warehouses to the cloud, for example, or automate the building of MDM, master data management systems with master data in there, automate the building of graph databases, streaming pipelines, etc. So the purpose is quite obvious. We're trying to shorten the life cycle, shorten the time to build. And automation, therefore, gives us major benefits. It helps us do that. It helps us free up resources to do more complex tasks. At the same time, it allows us to not only build these things once, but to automate the maintenance of these kind of pipelines and systems over time, which is even more valuable because things change. It also allows us to support different data modeling techniques, whether that happens to be entity relationship modeling or, Kimball style star schema or Linstead style data vault designs, support multiple kinds of data sources, change data capture and streaming data sources as well, and the ability to even roll back if certain problems occur and automatically generate documentation. So there's a lot of benefits to data automation software. But how do they work? Well, historically, they've been focused around data warehousing automation as opposed to just data automation. Difference being is that those tools have historically been associated with a single purpose in building a data warehouse. Now, if you look at this chart, you'll see that, well, the metadata exists in a number of places within a classical data warehouse architecture. There's the source physical, those systems, the physical data models within there. There is the mappings to integrate that data to go build a data warehouse. There's the logical and physical data models associated with data warehouses and data marts. And if your BI tool has a semantic layer, which several do, then that's also metadata that needs to be defined. Now, historically, data warehouse automation allows that metadata to be defined through the keyboard, if you like, with a developer who could then define that metadata, and then using that metadata, we can then generate the pipelines to build a warehouse, generate the physical data models for your data warehouse and your data marts, generate the pipelines to populate those systems and potentially generate the semantic layers for the BI tools. And of course, over time, we've seen integration with data modeling in order to be able to import data models for your data warehouse and data marts to do automatic reverse engineering out of source systems to understand what data is over there as well, and therefore not have to key in all the metadata, but get some of it in an automated fashion. The other major benefit is maintenance, not just a one-off build, but being able to make changes to this setup by automatically generating what needs to change and therefore quickly implementing changes, which certainly seem to be quickening as time goes on these days. So having said that, then the next question is, okay, now we've talked about data mesh and we've talked about automation, but how does automation accelerate data products within a data mesh uh, and work with data fabric? And so this is really where I think is a game change happening. And that is, for the last decade, we've really kind of been in development mode, building a lot of things, whether it's warehouses or machine learning models or data lakes or graph databases or whatever. But I think most of my clients these days are now saying, okay, we've had 10 years of doing this. Now, can we industrialize it? Can we really make this work like Henry Ford production line? Get this thing to really move like a well-oiled machine. So in other words, tidy it all up, speed up the development and accelerate the whole thing. And so we want a Henry Ford approach. We want, okay, let's get a production line going where we can build, let multiple teams onto the production line, but standardize things so that we can accelerate the development and build data products that can be shared or quickly developed and shared around the enterprise so as to speed up the ability to produce new high value insights from the data that we produce. So if we go back to this chart for a second, which we saw earlier, the different silos, data warehouse automation was really restricted to one of those silos, just building data warehouses. But as we know, we're dealing with a lot more than that. And so then the question is, can we expand the use of automation, not just data warehouse automation, but just call it data automation to be able to deal with these other silos as well? And so we revisit this chart and kind of say, well, what happens if you could add automation to data fabric? What happens if we could automate the pipelines that produce the data products and automate the pipelines that consume the data products and build for different analytical workloads? Is that possible? Because there's a huge opportunity here, right? Which is to potentially expand automation to go off and not only build data products, but then to consume them and build all kinds of analytical systems and much more rapidly without forcing people go back to raw data every time and exploit the metadata that may be sitting in data catalogs and glossaries to be able, maybe get more of that metadata automatically rather than have it all entered through the keyboard, and take advantage of streaming data and change data capture and be able to define governance policies once and apply them everywhere. And even add AI into the mix. Now, if you take the metadata that we talked about within a business glossary and a catalog, then we could make that metadata available to a broad range of tools, but let's restrict it to the bottom of the chart here, to data modeling and automation. Now that becomes pretty attractive if I can use common business terms for data products and build a model of a data product. And then also take this metadata and make it available to data automation tools where I know the common terms and I know the sources and I know the mappings. And then you say, well, what could you do? And then you could say, well, I could take advantage of that metadata in the catalog. I can then generate for all kinds of analytical use cases, not just a warehouse. I can build for feature stores for data science. I can build a graph database. I can build MDM systems. I can build physical data products, virtual data products. I can build data warehouses and data lakes like I've been able to do for a long time but I can take the software and broaden its use to generate all of this across the analytical ecosystem and dramatically shorten time to value whilst ensuring that we get consistent data because we're reusing data products and not reinventing them all over the place. So that should be cheaper to build as well because we're not reinventing. And so now you look at it differently and you say, well, if you add automation into this mix, and I can take advantage of metadata within a catalog and model data products, and then automatically generate the data, the pipelines to build the data products to be shared on the one side. So we speed up data production, we speed up data product production. And if we could get that across lots of teams, it would really speed up their ability to deliver on this without having to be highly qualified data engineers if they can get automation tools to help them do that. In addition, I can then use automation on the consumption side. So where the source is not the raw data sources, but it's the data product. Now what I can do is then generate, whatever, take the data products that I need and assemble them almost, for a feature store or to put master data products in an MDM system, or to build a warehouse by picking the data products that I need, or a data mart by picking the data products that I need, or a graph database. But it really accelerates the consumption side as well. So I get a double win. I get it on the production side and on the consumption side. And even generate virtual data marts across all of that if necessary. And so therefore what you get is that, well, companies are now in a situation where they have had for some time multiple analytical data stores, of which a data warehouse is just one type. And in fact, they may even have multiple warehouses. We've got data sources growing exponentially. We've got the demand for more data from pretty well all around the business, and a bottleneck emerging in centralized data engineering teams within IT and even in data science. We've got data lakes and lake houses emerging, and we're seeing some degree of merger between those, between lake houses and warehouses, for example, with open table formats. We've got agility needed in production of analytical systems. We want companies wanting the ability to automate a lot of this stuff. And automation now needs to really go beyond data warehouse. And I think that's where we're headed. We're going to go beyond data warehouse and use this to potentially build data products once and then consume them, and again automate the pipelines that consume them and build multiple analytical products. And so we get the benefits of end-to-end automation. And that's going to dramatically shorten the time to value and hopefully allow us to deliver insights more rapidly and, by the way, more consistently, because we're not reinventing all the time, we're reusing. So I hope that gives you a kind of an idea of what we could potentially do here. And with that, I'll hand over to Jamie.
Hey, Mike, this is Patrick. I'm going to jump in for a minute first.
Okay.
No problem. I'll just remind people that there is a Q&A button at the bottom. If you have any questions, we'll get to that at the end. And also, that was a lot of information to absorb. We'll be sending out a link with a recording of this webinar as well. And with that, I will turn this over to Jamie. Jamie Knowles is the product manager for ER Studio. And Jamie, you are on mute. There you go. I thought I'd warn you first.
Thanks for that. Very good. Thanks, guys. Cool. So I'm Jamie. I'm a product manager at Idera. So I'm going to talk to you about some of the products and what we're doing to support data fabric and data mesh. So you might be aware of one or two of the products that we have over at Idera. So within the data tools division, we've got quite a few products around data. Now there's four that really apply to the data fabric, data mesh story. And both of these technologies are really exciting to us because we've got some really good pieces that fit into that whole data fabric, data mesh story. I'm going to talk you through some of these in a moment. So at the moment, the traditional analytics world looks something like this. There's a lot of complexity in it. So we've got our data sources or our data providers over on the left, our consumers over on the right. Data can get from left to right through multiple mechanisms, through the warehouse, through the lake, through virtualization and streaming platforms. There's a lot of complexity in here. And really what we want to do is try and sort of streamline this and improve it. Now, Mike talked about a data factory. We talk about a data supply chain, similar sort of thing. So we really want all of the tools involved in that journey from supplier to consumer to work together. We want the people to work together. There's a lot of people that are involved. So we've got the business-focused domain subject matter experts that are going to be designing data products. We've got engineers that are going to be building those products. We need them all to be working together all across the chain. We want our automations that's going to kick in. And then we want a nice storefront at the front for people to be able to see, well, what data products are there? If there's a new data product that's required, can I request a new product? So we want all these sort of pieces working together, and baked in throughout, we need a governance framework. So if we're accelerating the journey of data from source to consumer, then we want to make sure that our data is protected along the way. The right data is getting in the hands of the right people. So in order to make this happen, the data fabric kicks in, and the critical pieces in there. So Mike's been talking about automations. We'll talk about some of our products in here. So we want to be able to automate the creation of the data warehouse, the pipelines into the data warehouse. Likewise with the lake and the virtualization and streaming platforms, the BI and analytics layer as well. We also want our data catalog. Mike mentioned the data catalog, being able to build a business glossary, understand all of our data sources and the data throughout the chain. And then we need mechanisms to be able to design those data products. And that's really where sort of models come in. So what we want to really avoid is sort of silos of data that's not being reused. We want to make sure that we've got good, well-designed, well-understood data products of fresh, good quality data that we know about and we can guarantee. So models like this are really important, where we've got a business glossary. We've got models of all of our data sources, the data warehouse, the data lake, the contents of that are well understood. If we're supplying data products as within streaming platforms, and being able to understand file structure is really important. And then there's the data. So having it right at the center, a set of common models that understands our data, and being able to build and design our data products from this, really, really important. So I'm not going to go into too much detail today, but really, we've got these 4 products that I mentioned. So those products are, starting from the left, ER Studio. This is a data modeling tool that allows us to both design and document data assets, source data assets, and not only that, but classify them against business terms, being able to attach them to business terms where data stewards have assigned policies and rules around the data. We want to be able to build an enterprise data architecture. So, okay, so what are the important data that the organization understands? Look at those sort of master data concepts like customer and products and order. And then from those sort of models, we can then start to design our data products. So ER Studio is a design tool to help us do that. WhereScape's our data automation tool. So as Mike said, traditionally used for data warehouse design, but now really sort of features within data mesh product design. So WhereScape, we can pass models from ER Studio. We started building these integrations between them to think about this end-to-end supply chain. So WhereScape will take models from ER Studio, and then running some pre-built policies will then automatically create structures in the data warehouse, create all the pipelines that feed it. We've then got Qbol, which is a cloud-hosted data lake product, where we can take semi-structured data. We've got all the tools that you need to run analyses on the data and then use that data. WhereScape and Qbol working together gives us a really exciting story around data lakehouse, where we can start to add some sort of formal structure to the information and the data in the lake. And then over on the right, we've got Yellowfin. So this is a really cool BI tool that produces great dashboards and reports. It's got AI components that can produce inferences on that data. So what we're working on is getting these 4 tools to work together and produce that supply chain with data governance baked in. So we've got integrations with tools like data governance platforms like Calibra. We're building integrations with Purview and a lot of the other data catalog tools out there as well. So that's what we're up to at the moment. So our mission is to produce that well-governed data supply chain. We've got our tools working together with lots of automations to provide that data fabric. With the data mesh side of things, we want to make sure that the right people are thinking about the right products, the stuff that people want and need to use. And it's all going to be driven by models that allow us to standardize, structure, and understand our data using a data catalog. Everything's connected to a governance framework. And we're designing and coordinating a really well thought through set of data products. So that was a real whistle stop tour of the Idera products. I guess now we'll go to questions.
Okay, very simple question for each of you, Mike and Jamie. Will the decks be available? Slide decks.
Absolutely.
Okay. Mike, you are on mute also.
Sorry about that.
Jamie,
yes.
okay. Jamie, you answered this question, but I'll let you expand upon it a little bit. Which tool of Idera is used for data cataloging?
Yeah, so ER Studio, being a data modeling tool, has a built-in business glossary. It can be used for a simple data catalog. Generally, it works with tools like Calibra and Microsoft Purview. So some companies will have very different groups of people that look after data governance, the data stewards. We've got our data architects that are traditionally using ER Studio. We've been working so hard over the last couple of years to sort of get those groups of people working together, get the tools working together. But ER Studio can be used as a simple data catalog.
All right. And Mike, a question came up. Does the data catalog contain metadata about the actual data itself? Can you search for specific values in the data catalog? Or is it more just a description of the structure of the data?
So typically, data catalog will contain metadata about the structure of the data, physical data names, data types, etc. But it'll also or in some data catalogs will let you even look at sample data within a particular data source. But certainly, it typically knows about all of the physical data names associated with data sources that you choose to scan with that data catalog, and also knows about a business glossary, as I spoke about, and often provides the ability to map from from physical data names to common business terms. But typically, it's not a database in the sense that you're not going to run SQL queries on it to query the data within your data warehouse. It's going to tell you about your data, not let you use it as the answer, if you like, to all data. There are some data catalog products which will give you sample data querying capability, or even the ability to launch a query against the data source, having discovered the data within the data catalog that you want to look at. But typically that query is running against the source, as opposed to you loading a copy of data into your data catalog.
Yeah, I know that with the WhereScape 3D design product, it can do some profiling, figure out number of unique values, number of null values, mins, maxes, averages, things like that. So I imagine that kind of data could potentially be stored as metadata.
Yeah, you often find increasingly now data quality metrics and things like that can also be a part of what's available via data catalog. But typically, you're not replacing your databases with a data catalog holding all your data. I mean, it's data catalog's job is to understand what data is available, but more than that, data discovery is one side. when you map to business terms in a glossary, now you got a business lens looking at your data rather than having to look at every physical data name that's out there. And so, in that sense, data catalogs are much more than than physical data names, and increasingly, of course, being used as a sort of center point for data governance, with the ability to define policies and stuff like that within data catalogs as well.
All right, here's a question I get to answer. Can WhereScape build pipelines from the catalog? And the answer is yes. We can import data from a variety of sources and use that to help automate the construction of ETL processes all the way up to creating the semantic layer that the analysts are going to be using.
And this is a great use case where ER Studio and WhereScape can work together. So ER Studio connected with a tool like Calibra, we can pull business metadata around the policies of data from the business glossary, add that to a model of a source data asset, and then send all of that to WhereScape. So WhereScape's now got all of the business metadata around the source data asset, including security policies. So then WhereScape can actually automate the security inside the warehouse structures, all based on the policies set by data stewards over in Calibra land. So that's particularly exciting.
Okay, a question also about WhereScape. Could you throw some light on the AI-based capabilities within WhereScape, if any? Off the top of my head, I can't think of anything. What I will do is I'll go to our product team and ask them about that, and see what we can come up with. I know there's a lot of intelligence built into the product that helps you build data vaults, sub satellites, links, dimensional modeling and things. So there's a lot of contextual intelligence built into the product.
This is Mike here. I mean, I think as well, I've just been doing quite a lot of work on generative AI and tools, and to be honest, we're still in the very early stages of seeing generative AI finding its way into tools. So we've seen some early examples of this emerging, but I think a lot more is going to happen in the next sort of 6 months or so. We're going to see a lot more of generative AI, bearing in mind that AI means more than just generative AI. Generative AI being GPT and whatnot, which is getting all the attention at the moment. But machine learning, is already in things like data catalog, and the ability to automatically detect sensitive data and whatnot. That's already done using machine learning. But I think the role of generative AI in data management tools, and already appearing in BI tools, with the ability to ask natural language questions and get answers. But I think we're at the thin end of at the beginning of of this, thin end of a big wedge right now. We're going to see a lot more of that coming in the next 6 to 12 months.
Yeah, I know that a lot of what's done in WhereScape and creating the ETLs and the data pipelines and everything is done through templates. And we've actually used ChatGPT to generate Python templates and things by describing what we want it to do. And it's generating Python code for us. So I wouldn't be surprised if that's integrated into the product and into a lot of different products sometime in the future, where instead of writing code or going through wizards or things, you're just in free-form English describing what you would like done, and it gets done. Mike, I agree. That's not too far off.
No, I certainly think, and I'm sure Idira too, cooking stuff in the labs here. I mean, there's going to be a slew of announcements over the next 6 months, I think, across the industry in general, and I'm pretty sure Idira will be in there with a whole ton of those as well.
A couple of very general questions. How do you ensure that data mesh project would be succeed, and how do you ensure that data governance is complied by different function teams within the organization? And that's just general project management.
General project management. I think the first thing that's going to happen here is the danger with decentralized data engineering is that it all flies off in different directions. And I think therefore federated organizational structure is very important. I think you need a program office. I think it's probably out of the CEO, office part of that, which is basically coordinating and tracking multiple different development teams across the organization, so that we all know who's building what and for what purpose. Obviously, the job of a CDO program office is to align with business strategy, and so that the development of data products is driven by outcomes. So if you're trying to reduce fraud, well, what data products do you need to help you do that? Or if you're trying to improve customer engagement, then, well, what data products do you need to help you build that? And so that it's not just everybody build data products and we'll hope we're going to use them, which is a field of dreams approach. It's entirely the opposite. It's business strategy led. It's outcome led. And so the way to do that is to have a common program office prioritizing these, and teams around the enterprise interacting with the program office, so that everybody knows who's building what and for what purpose. Then we get results.
All right, Jamie, does Air Studio work with Databricks and Unity Catalog, both reverse and forward engineering? Does it allow for modeling of the medallion structure, bronze, silver, gold? Can it work with JSON and data hubs in Azure blob storage?
Gosh, right. There's a few questions there. So we're just working on our Databricks support at the moment. So you'll be able to forward engineer, reverse engineer, do alter script generation for Delta Lake towards the end of our financial year. We'll hopefully be building in full support for Unity Catalog in there. That's that one. The JSON side of things, we've been doing loads of work over the last few years on JSON, being able to convert between hierarchical structures in JSON and relational models. And as I mentioned earlier, a big part of data product design is what will that final output be? And a lot of data products might end up as some sort of JSON structure. So yeah, very much so. You'll be able to design those data products with logical models in ER Studio, and then design the JSON schema that goes with it. And on the whole sort of topic of data product design, Mike's going to be doing a webinar for us again on September the 12th. He's going to be talking about data modeling and data mesh product design.
Yep,
I'll just briefly mention that the WhereScape tool itself, we just I think next week releasing our Databricks enablement pack. What that means is you can now use WhereScape to generate data lakehouses and other data structures automatically through WhereScape. We're pretty excited about that.
Interesting as well, just to kind of add to that as a general comment, rather than a WhereScape or Idera specific one. I mean, there's quite clearly integration going on now between data warehouses and lake houses. I mean, it's kind of ironic. People think, well, it's warehouse and data lake. Why do if I have a lake house, why do I need a warehouse? Actually, what I'm seeing is integration between data warehouses and lake houses. And the reason for that is the adoption of open table formats. Delta Lake being one example of that. There's also Apache Iceberg, of course, which is another example of open table formats. And as data warehouse database management systems now support open table formats, then the reason why that's happening is because it's much faster to get data out of an open table format than it is to get it out of a data lake file. So if you're just getting data out of a data lake, then you're at the mercy of the cloud storage system, which is nowhere near as fast as open table formats, which support things like hidden data partitioning and indexing and all that kind of stuff. So what I'm seeing is integration between data warehouses and open table formats. And given that WhereScape's whole heritage, if you like, is in data warehouse automation, it's kind of pretty natural that with the adoption of open table formats within a warehouse, that what Patrick just said makes sense. That you're going to release your Delta package. So I mean, yeah, that's the way I see it, anyways.
Second half of a question was: should one develop data fabric or data mesh first? From my understanding, the way I would explain that is data fabric is a tool set. It's an application. Data mesh is an organization. It's a structured way of doing things. So you can pretty much develop them independently. I'm not sure if one needs to come
Yeah,
before the other.
I think there's a big mistake going on here at the moment. People saying it's data fabric or it's data mesh. I don't buy that as an analyst. I think it's much more sensible to argue data fabric versus modern data stack in the sense that, you get a vendor like Idera with an integrated set of tools. There's also best of breed vendors out there trying to get together to integrate their tools with each other in order to try, and there's equally also, single vendor data fabrics out there, but like what Idea is rolling out. But I certainly don't believe it's data fabric or data mesh. I mean, it's absolutely the case that people are building data products in a data mesh using data fabric. I think that makes much more sense to me. But clearly the reason data fabric is important, it's because people have data now scattered across multiple clouds and the edge and on premises and software as a service apps, then clearly we need connectivity right across that distributed data estate in order to be able to get at the data to produce the data products that we need. But I think you're right. Data fabric is a software platform, not an alternative to data mesh necessarily.
Okay, two quick questions, and then we'll finish up. Data catalog is basically using metadata in the source system. So if the source data doesn't have the metadata information, does the separate data catalog tool, is it still useful? If there's no metadata we can extract directly.
100% still useful, because data catalogs often these days have got machine learning models built in. So even if the metadata is missing, they'll still recognize the data. And often they can do machine learning clustering, so they can cluster similar values. So if you then manually label one piece of data as a human does it, then the catalog will say, oh, okay, so they manually labeled one of these, but I know what all the others are, because I already clustered them using machine learning. The catalog will label everything else. So absolutely. And in fact, that kind of technology is already baked into a lot of data catalog products.
And I think this is where the data architecture team can come in and help. I think we're still a long way off the machines being able to look at data and tell you exactly what it is. You're always going to be reliant on human beings to
you are. I mean, the exception being sensitive data types, because with GDPR and CCPA and other similar data privacy legislation across different geographies around the world, what we're now seeing is machine learning models baked in to recognize sensitive data in different countries, different regions around the world, in order to automatically label it whether or not there's metadata there or not. And that's happening in order to quickly identify sensitive data without the need for humans, for obvious governance reasons, because clearly you've got to protect sensitive data wherever it may be, and that doesn't even need human intervention these days in many cases.
And it's not even an all or nothing thing. If a data cataloging tool can do 80% of the work through pattern recognition and things like that, that's a huge step forward.
Absolutely, yeah.
But again, the ideal is having a collaboration between the AIs doing their automated part of the story, the human beings, they're adding their knowledge to the story.
Absolutely.
All of this working together. That's what we're really trying to work with.
Absolutely.
Right, and then lastly for Jamie, would ER Studio enable people to maintain conceptual, logical, and physical models in one model?
This old chestnut, this is a cracker and quite a conundrum, and I think you can have conceptual models for different purposes. So if you're talking about the sort of design process of a particular data asset, then in ER Studio right now you can create conceptual entities as business data objects. You can stick inside them then the sort of more detailed entities and then generate the physical from it. So that's something we can do right now. If you're talking about a more sort of enterprise conceptual model, generally we hold that as a separate model and then connect it using universal mappings to your enterprise logical and down. There's a lot of benefits to doing that. It's been a tricky one over the years as to sort of what people's definitions of these things are and what do they want to use them for. But always trying to improve on all of that sort of stuff. happy to
Right.
help.
We ran a few minutes over, but I'm perfectly happy with that. I think there's a lot of good information here. Mike and Jamie, do you want to tell us one more time about the follow-up webinar that Mike's doing?
Yeah, so September the 12th, same sort of time, and you can find it listed on our websites. Mike's talking about data mesh product design and the importance of data models. On this slide here, there's a whole bunch of resources. Again, we can send out these decks, so you can have a look at these links.
Yeah,
All
I
right,
think
so,
that's one of the things I would say. I mean, you know, the one thing that seems to get forgotten about a lot of the time and a lot of the data mesh discussions that go on is data modeling. And if there's ever a time where data modeling is needed, it's now. I mean, and certainly a key skill for any data engineer, or indeed, I keep hearing the term analytics engineer these days. You know, if you've got data modeling skills, really matters. And I really think, you know, the last thing we should be letting go when it comes to building data products is data modeling. In fact, it's, you know, yes, you can come up with different data names, nice business data names for a data product. You've also got to come up with a schema for it, and so data models are very important. But I'll be talking about that in the next webinar. Yes.
yeah, we had WhereScape hosted Ken Graziano in June, and the entire webinar was around the importance of data modeling, especially in the age of AI. If anyone's interested in that, they can contact us at moreinfo@wherescape.com, and I can gladly send you a link to that. So again, Mike, Jamie, appreciate your time, appreciate your effort. For everyone who's attended, thank you very, very much. As I said, we'll get a copy of this webinar sent out for you, or if you want to share it with somebody else. And I hope you enjoy the rest of your day. Thank you all.
Thanks.
Thanks, everyone.